All right, everybody. So we're gonna continue today from the last part that we got on the WebAssembly from the ground up book, in which we're looking at how was this magical number composed, or how the minimum how the minimum viable compiler was composed, and we could see that it actually used some hex. It had a representation in which if we wrote the backward slash zero wasm, we could actually place it at the very first top of the file, and we created like a uint808, where we'll be able to create a valid wasm file plus this version number, which basically meant that it's version 1. And we're going to continue. Let me see here. We're going to continue going in the minimum viable compiler group. This is what when we were talking about binary data, from raw bytes to meaningful fragments, mag number. Okay. All right. We're going to continue from here. From raw bytes to meaningful fragments, let's return to those 8 bytes. 0, 97, 115, 109, 1000. We're using the compiled void lang. To understand their meaning, we need to learn about the first 2 values in WebAssembly module binary. I think we did read this, right? The encode function. Now we go, yeah, of course we did this. The version number, the magic. Now we use the flat to infinity from bytes. Doing nothing but with an empty function. But you may be thinking that's not even a program. Yeah, right? Section basics. Here we're talking about the section. Yeah, this is where we actually left. I'm going to continue from here, from the section. Section basics. Let me check the camera. Okay. The sections in a WebAssembly module have a common structure consisting of 3 parts. The section identifier is a single byte that specifies which section has been defined. For example, the type section has the ID 1, and the function section has the ID 3. A size field, which represents the size of the contents, like the section payload in bytes. The contents of the section, the structure of this can vary based on the type of section, but most of them are structured as a list of zeros or more entries. To save space, and here's the chart. It says to save space, all integers in a WebAssembly module are encoded with a variable length encoding. This means that the algorithm will try to encode the value using only 1 byte. And if it doesn't fit, it will try 2, then 3, and so on. The version number, which appears in the preamble, is the only exception. It always takes 4 bytes. The encoding algorithm WebAssembly uses is called lib128, short for Little Indian Base 128. We covered it in the last video. It can encode up to 128 to the 7 unique values per bytes. So for unsigned integers, any value from 0 to 127 can fit in a single byte. And for signed integers, minus 64 to 63. We'll avoid writing a full implementation of lib128 right now, but there's a trick we can take advantage of. For non-negative integers that fit in a single byte, no encoding is necessary. Since we are creating small and fixed module, data restriction is fine for now. Now that you've learned a bit more about sections, we can now handcraft a module with a section required to define a function. So we got the magic, we got the version. Now we got the type section, and the section identifier, section size in bytes, number of entries that follow. This kind of reminds me of what? Of WebAssembly, the text format. It kind of follows that same convention, right? But here it's more like the binary no, not binary, but like the integer representation that it was talking about. We got the type section, we got the section identifiers, section size in bytes, number of entries that follow, and let me count the entries. So entry 0. Okay, so we got this type section, we got the function section, we got the code section. Right, so it always have one in here because we only have like one section of the code that is following. We define the types. Something that we need to remember is that WebAssembly does not use named functions. If we recall correctly from the previous one, let me see if I can find it in here. So you can see in here that this is only like a placeholder. Let me see. Okay. So we got the type section. Okay, so we got the session size in bytes. Let me see, section. The type section contains a function's type signature. It's about saving space. If multiple functions share the same signature, they can refer to the same entry in this section. We're going to do this. We're going to create duplicate. I'm going to stack it together. Now I'm going to tile the stack. It's one of the things that I love about Vivaldi. And we're going to come in here. So the type section in here contains the function's type signature. To us humans, a function may be defined. I think that we gotta move a little bit. Here's another representation of the same module, because I gotta understand what is this used for. We got the module binary. We also got the module binary. We got the outline, string magic number. This is how we define the module, which was here the ASM. That we define the magic number, which was here, magic version, which we define it in here using hex. And now we got the type section, byte section ID 1 type, right? Section ID 1. Byte count 4, entry count 1, byte function type. So as you can see, everything. So here is how we define the func type, which we read from the last one that most of these numbers, which are kind of magical, are actually part of a label system that the committee came up with. So there are a little bit of fixed. We can either look for a table or just learn them. And these are the result types, function, the code. Let's verify that it is indeed a valid module. With a function. Okay. No blank bytes. Okay, we're gonna get here. I'm gonna copy these. We're gonna come here to Neovim. I'm gonna make this a little bit bigger. So you can see it. And we're gonna come here to 10K. See? And we're gonna paste this. And we're gonna create a, let me see. Here the test. Handcrafted. This is how handcrafted. Module with a function. Module. So basically what we're doing is that we're copying right here 3J 14 and instead of the compile void lang, we're going to use No blank bytes. What's it? What is it actually does? I want to see it very carefully. So instantiate. Oh, it actually uses a UEN8 array, right? Because that's how it reads the. Okay, new u. I forgot the naming. It's UN. What? Iterate. No blank byte. Oh. Formatter failed. Why did formatter fail? What did I do? What did I do? What did I do? What did I do? Flat infinity. Did I eat like a comma here or something? 0 to 60. Okay. You know, this is why it's good. But the thing is that I forgot about that because it's all about repetition. Come on. There we go. Node chapter 1.js. Unexpected number. Names of type section entry. Oh. Got it. We got it. We got it. Clear. Node. Okay. This one passed. Right? Now we're going to come and continue here on the as more important detail in this is that the sections in a module must appear in ascending order by ID. For example, a type section whose ID is 1, we found the ID byte section ID 1. Okay, let me continue here. Let me come down. Section identifier, which is this one. Section identifier is this one. Section identifier is this one. So ID is random. And this is what I'm going to try. I want to try tinkering with a little bit. For example, a type section whose ID is 1 must appear before the function section whose ID 3. Okay, let me try this one. So this should probably break. If I come here and specify 15, and I wrote here in note, oh, it is unknown section code 0x0f. Interesting. So I do have a question, because if I change this to 2, right, and then I come here and I say node again, chapter 1, it says expected 96 bytes, fell off and at 12. Okay, I want to understand this, because the book is saying that must appear before the function section whose ID is 3. So Are these fixed? That's what I want to know. All right. Yeah, they are fixed because it's saying you may have noticed that we skipped one section identifier. Went from 1 to 3. This is because the section ID with ID2 is the import section and we weren't importing anything yet. Right. So this must be 1. This must be 1. And we gotta save this. It says adding more structure. The module as a flat array of bytes may have been useful to get started, but it's not a sustainable way to write a compiler. Our goal in this section is to build a small library of functions for constructing WebAssembly modules, which will be used in the rest of the book. As much as possible, these functions will match the naming and structure that's used in the official WebAssembly specification. The names are sometimes a bit terse, but by doing it this way, we can have a very thin layer over the actual module format and avoid introducing any new idiosyncratic abstractions. Okay, first let's write some stubs for LEB128 128 encoded in integers. As we explained earlier, we can avoid doing any actual encoding if we only accept positive values that fit in a single byte. Here's a function for unsigned integers. Okay. I start value is negative. Okay, I got it. EV, okay. U32. Okay. It takes a number as an argument, returns an array of bytes, which is the unsigned LEB128 encoding of that number. For now, we only accept integers to be trivially encoded in a single byte and fail otherwise. Okay. Okay. So this is going to be for unsigned integers. I'm going to come here. I'm going to come and we're going to come here to utils.js, which I did have open. And yeah, but I'm not going to write all those functions. It's for functions U32. We're going to get a number. And we're going to come here, assert, and number. Let me write it here. Number should be equals 0. Otherwise, we're going to assert. And we should definitely check for nans, but I'm not going to do that. If number, let's say 8 or equals 128, right? We're going to return the number in here. And else, I'm going to throw new error, not implemented exception. I'm going to do the same for the I32. But what is it actually doing? So this one is only checking the boundaries. V, right. Right, it can, wow. Whoop. I switched buffers, Yeah, it cannot be like that. So in here, I32 should be, this can actually go. And number should be number equal, that's minus 64 and number 64, right? Or V minus, oh, is this condition true? This condition is true. Oh. else statement is I don't like the else statement. As we described above, sections share a common structure. Here's how the structure is defined in the spec. Each section consists of a 1 byte section ID, which we can see in here, the U32 size of the content in bytes, section size in bytes, the actual contents whose structure is dependent on the section ID. Let's define the section function. Okay, we're gonna have function section ID and contents. Contents.flat infinity.length. Return ID, the size in bytes, and the contents. Okay. All right. The contents are also going to be an array, and I suppose that you make the count. So it says the actual content whose structure is dependent on the section ID. The U32 size of the contents in byte. Got it. Got it. Okay. I'm gonna come here. Export function section. Right, section was it? Yeah. Pass the ID and the contents. Come in here, and we're gonna get the const and size of section. Was it? Size in bytes. In bytes, we're gonna be content dot flat infinity dot length. You're gonna return. It was the section ID, which was here. Now the U32 of size in bytes and the content itself. Okay. The contents argument is possibly a nested array of bytes, so we flatten before getting the length. For most sections, the contents are a possibly empty list of entries in the binary format. These are known as vectors, or vec as short. The contents are a possibly empty list of entries. In the binary format, these are known as vectors, or vec for short. Here's how they are defined in the spec. Vectors are encoded with their U32 length followed by the encoding of their element sequence. Let's implement a function for encoding vectors, again following the naming from the spec. Hey, Barry, thank you very much for the follow, Dan Black. I didn't see it. That's awesome. Thanks. Let's implement a function for encoding vectors, again following the naming from the spec. So this means that U32 elements.length elements. Getting the elements length. Vectors are encoded with their U32 length followed by the encoding of their element sequence. Vectors are encoded with a U32 length that I understand, followed by the encoding of their element sequence. So that means that this is going to be transformed. We go to vectors, again following the naming from the spec. Okay, function back. Export function vec. We're going to continue here with elements. And we're going to return an array of elements. We're going to encode it. Yeah, we're always encoding in U32. U32 elements dot length. And here elements. Yeah, that's it. Let's introduce more functions by following the spec. First, for the type section. Const section ID type equals 1. That means it's the type section, right? I think we could have done the same thing in here. Because this is a label that a function type is using. I see. So what we're trying in here is we're encoding these things into these values over here. Okay. So we're gonna come in here. Export function, func type, receive a param types, result types, and we're gonna return, which is the label, back of param types. We're creating a vector in here, and back of result types. Okay. Export function, type sec, which is the thing that we defined earlier, func type. And here, return section. I don't know why. No, I'm just gonna write it here. I don't know why we would actually extract it. This is the func type. Function section. Type section. You see, it's defined as the byte 0x60, followed by a vector of parameter types and vector of result types. So we're basically seeing the entire w3.org. This is a section. This is lovely. I love following the standards. Custom section. Like implementing these tables or these documents are very important. Data section, okay. I'm just gonna close it and look for it later. And okay, we already defined this. So everything that we're doing here is for define the type section. This is a type section. Func type, now the definition for the function section. Func_sec is defined as a section with section ID 3 that contains a vector of type indices. So we're gonna come in here. I'm going to write it here. No. And I'm just gonna write a comment. Let's say type section. Come in here, and I'm gonna write in here code section. Export function, code, func, const size in bytes. Same thing, func, flatten infinity dot length. It's the same thing, return u32 size in bytes. Got the func, right? Export function, func locals, body, return vec locals, body. Export function code sec codes, return section ID code, which yeah, I can see why they're actually doing this. They're extracting it. Yeah, it makes it clear. Okay, I can see it. Const section ID code equals 10. Here 13. Const type ID code equals 1. Come here, 6F1 type ID code and action ID code. Oh, we always return an array in here, or not, section. Oh, okay, section fact codes, and let me see something. Okay, a section, it's always comprised of 3 parts. That's what we were seeing, right? 3 parts. Wait. The ID of the section. The section size in bytes. Number of entries that follow. Code sec. Type section. Okay. Type sec. Type section. Okay. Okay. I think that we're slowly gonna understand more. The code section code sec has the ID 10 and contains a vector of code entries. A code entry consists of the size of the function code in bytes, the actual function code. And I think these are all references. Oh, right. The size of the function code in bytes and the actual function code. A function's code fun consists of declaration of locals, local variables as a vector. We'll define locals later once it's actually required. And the function body, which is a sequence of instructions terminated by the end instruction, so basically the code. Hey, we've encountered our first instruction. As you might have expected from the name, the end instruction doesn't do much. It just marks the end of something. It's always the last instruction in a function body. You make it a little bit easier to read. Each instruction is encoded by an opcode, which is a single byte identifying instruction. Operation code, I think. Each instruction is encoded by an opcode, which is a single byte identifying the instruction. Let's create a constant named inster, short for instructions, to map from instruction name to opcode. Okay, I'm gonna do the same. I'm gonna put this at the very top. Well, after the back function, 26 export function, export const. Oh yeah, I just added it at the top. Export const instructions, and at the end it's going to be 0x0b is n. But anyway, this is like an enum basically. In JavaScript, whenever you write this, one thing that I like to do is to use object.free so nobody messes with the object. And this works really well with TypeScript as well. With our new functions, we can write a no operation lang compiler in a way that's both more readable and follows the specs more closely. Okay, so we want to come in here. Buffer. I have to learn many of them. And do we have like a function? Compile. I remember. No, we don't. We don't. By the way, before this becomes a mess, 7K, 10K. Well, I understand. This can also work. So when I say function compile no blank, and we're going to pass the source code. It says if source. Well, I think that I can just assert source, right? And say source must not be empty. Say const mod will always pass the magic number, the version. I'm going to create a new utils.js and I'm going to pass it in here. I'm going to say export function. And we're going to return how is this called? It's not parse. Let's call this function transform or T. It's gonna be bad, very bad naming. Let's say var wasm array. Wasm array. Dude, naming is so difficult. And we're gonna receive a mod. I always love to check if it's an actual array, but for this video, we're not. Return uint8 array dot from mod dot flat infinity, and that's what we're gonna do. Gonna continue. Come back here to chapter 1. And var. Got the magic version, the version, type sec, okay, func type, func sec, type idx0, code sec, code func, instrument end, return var mod. Okay, and then I think we're going to write the test. We start with the preamble, right? Followed by the type section, containing one entry for a function with no arguments. And no return values. Remember, this entry is a type signature that could be shared by multiple functions. It doesn't necessarily represent an individual function. Then comes the function section with a single entry, which means that this module has a single function and its type signature is found at index 0 in the type section. Then comes the function section with a single entry. Finally, we have the code section. Then code the function section with a single entry, which means that this module has a single function and its type signature is found at index 0 in the type section. Right. So what this means is that the type IDX, I am getting it now. So the func sec in here, it's actually referring, I'm just gonna get in here. So this type IDX, what it's actually saying is that you should refer this very first index in here. And this is the signature index that we're actually referring. Because the thing about WebAssembly is that we define the different ways, since this is a very efficient portable format, right? We first define the signature of the function. What this is meaning, we're gonna come in here. I gotta look for something that I can draw. I'm gonna come in here. No, they changed it. It's been so long since they changed it. Oh yeah, they have like a whiteboard mechanism. Okay, so here's the thing. What it's actually saying is that you have like a traditional function, right? And it has, it generally you have like, for example, you got the parameters, right? You got like a parameters. You say like a number, and you got like I32, and then you're probably gonna have like say you have like two numbers, you want to add it up, like, and then you got num2, another I32, right? And you want to add them up. So what this is actually saying is that you want to refer, this type index is actually referring to the definition of these two things. Basically, it means that you're gonna extract this portion of the function. I'm gonna write it differently. I think like writing some TypeScript code is going to, nope, it's not. Did I need, boy? Let me write, I gotta do VS Code. So I'm gonna create a TypeScript file, km TypeScript, just so we know. And I'm gonna say that we have a function at number. Say the a, which is gonna be a number, and b is gonna be a number, right? Now, what this is actually saying, is that you're gonna define a type, saying it is typeless, right? It is typeless. I mean, it is nameless. So it's something like this. It's what we call like a lambda in several languages. And there are like no return types. Okay, let's do it differently. I think that what this is trying to do, we're trying to do something like this. It's basically like undefined, but this works. So this is the equivalent. We can say function. No, this is different because since it's a type, we should do something add another number. Well, I'm just driving you crazy right now. B number, 2 number, B number. So basically you can do the same thing. You say add number. Say add other numbers. It's like you can share the type signature, right? And this is kind of a bad example because JavaScript lets you change things. I mean, it doesn't force you on doing things, but this is something very similar. What function is actually doing is that it's referring to this type add number, and with this type is that you can define as many of the other ones. You gotta think about all the space that you're saving when you have humongous programs. This kind of reminds me a little bit of Tailwind in some sort. If we can create like an analogy, that you got the entire utility functions that instead of specifying the individual CSS classes that may share several properties and values, you got this utility class which only has one thing. And the preamble is that as if your program keeps growing and growing and growing, it won't grow at an exponential rate. It may stay the same because it just shares the same number of styles. Heck, like I would say that not in this case, but in the case of CSS, you would have a limit or a top limit on how big the CSS can become if you only use Tailwind classes. And here, since you have possibly like an infinite number of combinations, you're probably not, but you're likely to have very little to no things. So I may guess that in this book, we're gonna create some sort of mapping if it becomes more complex that will refer to the different type sections that we're defining. Okay. Okay, let us continue. Make this bigger. Then comes the function section with a single entry, which means that this module has a single function and its type signature is found at index 0 in the type section. There you go. Which means it receives a single parameter and it returns something else, I think. Right? So we're going to compile our thing. We're going to come in here and we're going to test it. We're going to test it. Test compile no blank compiles to a wasm module. Async. And we're going to say const instance module of await WebAssembly assembly dot instantiate compile no blank. Nope. Where's the typer? Dude, I'm about to just go do VS Code. True. Assert strict equal instance of assembly dot module true. Declaration or statement. Where am I getting it wrong? Okay. Oh. Compile nope. And WebAssembly. Dot instantiate compile no blank. Oh, I found it. There we go. Now I can come here. Yep. Oh, we failed. Source must not be empty. Wait a minute. Oh. My bad. Oh, we actually got it wrong. Oh. Magic version, funk type. This is good. I need the yellow speed. You know what? I'm losing a little bit of time in here. And I want to make this stream longer than it is. So I'm just going to close this. Going to open the wasm Groudup. Done save. And we're going to continue here. What are all the sounds? Instantness. I thought I had some LSP. Oh right. Type sec is not defined. Yeah, of course. Forgot about all of my imports. So I'm gonna go type sec, func sec, code sec, func type, type idx, code, and func. Right, where's type idx? Oh. I think I never defined the function section. I actually jumped it. Oh. Function section. So I'm gonna copy this. I didn't define it. Oh, this is interesting. Okay. Chapter 1. Compile nope. This is screen reader. I'm gonna detect it. You want to? I'm gonna turn it off. Assert is not defined. Func.flatten is not a function. Func. 973. Code. It should work. $110, right? Utils.js 73. Func.flatten infinity.length. And to debug this thing, console.log type of font. Load the little chicken. Clear. Let's say node. Object. Right. True. Func.flatten is not a function. Oh, so that's why you didn't use assert. Line 120. Okay, we got it working. Okay, we got it working. Now we can continue. Remember, the purpose of the function section is to declare all of the functions that are contained in the module, but it's a very minimal declaration. It only specifies the type signature of the function. We add index into the type section. Functions declaration do not contain a name because inside a module, functions are referred to by their index into the function section. The function bodies appears in the code section in the same order as in the function section. Here are the definitions for the code section. The code section has the ID 10 and contains a vector of code entries. A code entry consists of the size of the function code in bytes, the actual function code, a function's code. Yeah, it's like as you can see, like we're going diving into a tree. Function's code consists of the declaration of locals as a vector, the function body, which is a sequence of instructions terminated by the end instruction. So where we were at. Finally, we have the code section with a single entry for a function with no local variables, and a body with only the end instruction. Even when a function is defined, it's not automatically exported, which means we can only call it from within the module. It may feel like a lot of work to write all these functions just to do something relatively simple. The good news is we're almost done. Just a few more things to define, and we won't have to worry about the module format for the next few chapters. Oh wow. To make our function accessible from the outside, we'll the function to the export section. But first we need to define some export specific functions. Okay, so in this one, we have not defined this. Haven't seen this. I'll come back in here. Maximize. And I'm gonna open utils. And I'll write it. So it actually, give me a second. Because I think this was recently updated. Okay, so we're gonna come here, say const section ID export. So one thing, that means that this comes before the code section. Yeah, we'll define first the type. We got the function. I'll write it here. I'll move it here. And say export section. I'll write it here. Oh, no, that was not it. Okay, that was it. And export function name. Turn back string to bytes. Change the bytes. Right. Okay. Export function, export namespace, export description, return name or description. Oh, export sec, exports, return section, section ID, export, exports. Func IDX. X U32X const export description. Aren't we shadowing those things? I don't like shadowing. Like, it depends, because in JavaScript you're very propense on making certain mistakes. Func IDX. So, damn, there's, you can see the tree structure in here. You can see it a lot. All right, guys, I think I'm making a call. I think we're gonna leave it here. My baby's just about to wake up and I gotta look for him. So I think we're gonna continue tomorrow. We're still like in chapter 1. There's a lot, but we're going very slowly because we're trying to understand how the intricacies work, right? So